Hey everybody. So we're looking at 4.1 part 2 today, angles formed by intersecting lines. Before we get into it real quick, let's do a warm-up referring back to what we were learning in our last lesson, because a lot of these words we learned in the last lesson we're going to be needing to know today. Okay, so let's recall what these mean. So on our warm-up here, it's asking us to determine what angles are complementary, supplementary, and or adjacent. All right. So take a second, copy down this warm up, maybe try some of these on your own, try to figure out what pairs of angles here are considered these three things. And then we'll go over it in a second. Okay, so here's a quick reminder. Okay, complementary angles are those angles that add to 90 degrees, two angles that add to 90 degrees. Okay, supplementary angles are two angles that add to 180 degrees. Okay, and adjacent angles, it's not about angles adding up to a certain measure. Adjacent angles are angles that share a vertex and a common side length. Okay, so that's what those three words mean, and let's break it down. Okay, so let's start by looking for some complementary angles. All right, so two angles that add to 90 degrees. I'm looking around and I'm thinking, okay, 41, those don't add to 90. 41 and 49. Yeah, those would be considered my 90-degree angles. Sorry, my complementary angles because they add to 90, right? 41 plus 49 is 90. Um, we need to name these angles though. So let's start just off to the side by saying, okay, I'm just going to do a comp for short for complementary. So my complementary angles, okay, is going to be this one. Again, I'm not going to just say 41 degrees. I'm going to name this angle. Okay, here's a little reminder on naming angles. All right, this angle right here, we cannot name it angle G because if you notice, it's not the only angle that has G as its vertex. This one also has G as its vertex, this angle. We wouldn't know which one we were talking about. So when that's the case, we have to name the angle going around, starting on a side length, going around the vertex to its other side. Okay, so I can call this thing angle FGK. All right, and we learned this a bit back, and it's still a super important thing. So FGK. Okay, just a little reminder. I could have also named this angle KGF. I could have gone the other way around. Okay, but just a little reminder. I could not have called this angle GFK. Okay, I can't start at the vertex, go to a side, and then jump to another side. All right, it doesn't work that way. We got to go around the angle as we name it. Just reminders. All right. So yeah, there's the name of that angle. The other angle we're talking about is this one, right? Here's the thing. This angle has K as its vertex, and there's no other angle that also has K as its vertex. So we can actually just call this angle angle K. So I'm going to say and angle K. All right. But just so you know, we could have also called this GKL or gone the other way and called it LKG. Okay. So some nice reviews there on naming angles. Very important. Okay, so let's look for some supplementary angles. So I'm just going to use sup as my shorthand, and I'm looking for two angles that add to 180 degrees. All right, I'm looking at, these two, doesn't look like it. They're close though. But I do notice that 131 plus 49, yeah, that would give me 180 degrees. So there are my supplementary angles. All right, so let's start by naming this one right here. Right, I'm going to go around it starting on side. I'm going to call this thing angle HGK. Okay, and just by the way, I could have called it KGH if I'd like. And just remember, guys, one thing, when I name an angle, that middle letter will always be the vertex of that angle. Just something to keep in mind. Okay, so there's that. And the other angle, this one here, again, we can just call it angle K. All right, last thing is two angles that are considered adjacent to one another. So I'm going to do ADJ for short for adjacent. All right, and just a reminder, adjacent angles, let me just kind of draw them, would be two angles that share a vertex and a side length. Okay, so that would make these two angles here considered adjacent to one another. Same vertex, shared side length. And I'm looking through here and I'm noticing that, yeah, these two angles here and here, they share the same vertex and they also have this common side. All right, so they would be considered adjacent. The easiest way to just think of adjacent angles, two angles that are touching one another. Okay, touching one another is usually the easiest way to think about it. All right, so let's start by naming this one here. I'm going to call it FGK, just like before. So angle FGK. And this angle here, I'm going to call it HGK, just like before. All right, so a lot of really, really good review there. Review on these terms, review on how to name angles. That's some good stuff. We'll need that for today. All right, so jumping into what we're doing today, I guess real quick, go ahead and get the title here, and you can copy this example. All right, so taking a look at the example here, it's saying that angles 1 and 2 are vertical angles. Find x, vertical angles. All right, that was another term we learned from the last lesson. Let's, off to the side, let's draw a little example of what vertical angles look like. If you guys remember, vertical angles are angles that are created when two straight lines intersect one another. All right, and they are the angles that mirror one another. So, for example, this angle here and this angle would be considered vertical angles. All right, here's the big thing to remember. Vertical angles are congruent to one another. They are equal to one another. All right, so if you want to put a little reminder, you can put a little congruent symbol. All right, just to remind you, oh, vertical angles, they're always equal. Okay, this is asking us to find x. All right, we don't need to draw it out, but let's put the information here. Let's say that this is angle 1 and this is angle 2. Okay, they're saying that angle 1 is 2x minus 3. And angle 2 is a 5x minus 12. All right, again, we don't have to do this, but I want you to kind of visually see what's going on. All right, if these two angles are considered vertical angles and we want to find x, when they say find x, they're basically telling us make an equation out of this information and solve. All right, well, what equation can we make out of the information we have here? Again, we know vertical angles are congruent. Okay, in other words, they are equal to one another. So that's exactly what we can do. We can say a 2x minus 3, this angle, equals the other angle, 5x minus 12. Okay, that's kind of the big part. If you can make the equation from here, we're just solving simple algebra. Yeah, so it's all about knowing how to make the equation. Okay, so first thing I noticed, variables on both sides. I'm going to bring them to the same side. Doesn't matter if I bring them left or right, just a reminder. I'm going to bring the 2x over to the right because I like that this will give me a positive number. I like positive numbers. All right, so those are gone. Have a negative 3 on the left. On the right, looks like I have a 3x minus 12. All right, now I'm solving for x, right? Remember, I don't care about this minus 3 that's on the left. It's on the left. It's away from the variable. I am happy. I care about these two numbers, this 3 and this minus 12. Okay, remember, when we solve, deal with addition or subtraction first. So I'm going to get rid of a minus 12 by adding 12. Okay, negative 3 plus 12, or remember, you can think of this as 12 minus 3, gives us 9. 12s are gone. On the right, we have a 3x. Okay, the last thing is solving for x. 3 is being multiplied, so we will undo it with division. 9 divided by 3 gives me a 3. Okay, which, by the way, this is going to give me 3 equals x, right? I'm going to save myself a step, flip-flop it, write it as x equals 3. Okay, and just remember, always double check. Did they say just solve for x, or do they want me to then plug it back into the problem? This one just said find x, so we're good. But always double check your directions because sometimes they want you to plug that number back in and maybe find the measure of angle 1 or something like that. Okay. All right, let's keep going. So I'm gonna have you guys go ahead and try out one of these problems on your own. Okay, here's the thing though. If you guys notice, the directions are different. They're telling us that angles 1 and 2 are complementary angles. All right, so just a little reminder. I guess let's draw the picture and then I'll have you guys try the problem out because I want to make sure we're on the same page. You guys remember, complementary angles are two angles that add to 90 degrees. Again, if you want to put that into your notes here and just remind you, oh, okay, add to 90. That's what complementary means. Okay, start memorizing that. Okay, so they add to 90. So if I wanted to draw a picture, it's not required, but I know that a right angle is 90 degrees, right? Usually we represent that by putting a little box. Okay, so here's a 90-degree angle. but it's two angles that make this. So let's just kind of break it up. So here are the two angles that add to 90 degrees. Okay, this is what we're dealing with. And let's just, for example, we can call this angle 1, call this angle 2. Okay, and if you wanted to continue to put this info in, we can say, okay, angle 1 is a 4x plus 8, and angle 2 is a x plus 2. Okay, here's my question that I want you to ask yourselves. Am I going to make the same equation for this problem as we did on the last problem? Okay, the last problem we had vertical angles. Vertical angles were congruent, so we set them equal to one another. Are these two angles congruent to one another? Is that what it means to be complementary? Okay, no. Okay, that is not what it means to be complementary. These are not equal to one another. What we know is that they add to 90 degrees. Okay, so that's what you need to now do. Go ahead and make yourself an equation. Add these two angles together, set it equal to 90, and then solve. Try it out. Okay, so hopefully you're able to make your equation. So I'm going to go ahead and do it. I know that this angle, 4x plus 8, plus this angle, x plus 2, when added together equals 90 degrees. Okay, that's your equation, and that's really the big thing. You have to really be careful on these problems. It's going to be very tempting to just set them equal to one another or add them together to, and set it equal to 90 or 180. You have to know what you're doing. That's why knowing the definitions of these words was so important. Okay, here's just a basic, algebra thing. I notice we have multiple variables, but they're already on the same side of the equal sign. So unlike the last problem where we had to get them to the same side, they're already on the same side. We can just combine them together. Okay, so a 4x and an x gives me a 5x. Okay, and then I can combine an 8 and a 2 to give me a 10. Okay, and then on the right we have 90. Okay, now we have a two-step equation. So we can get rid of our addition or subtraction by doing the opposite operation. So I got 5x equals 80. And from here, get rid of the 5 by dividing. And it looks like x is going to equal 40. Oh, wait, 40. What? No, that's not right. Why am I blanking on 80 divided by 5? I was thinking 2. 16. There we go. Yes, calculators are your friends, even for your math teacher. All right. First thing, find x. Is that what they asked me to do? Yes. Okay, so I'm done. Okay. One real quick comment. I want to go back to this thing. Remember, the variables were on the same side. If you had the idea to subtract x from 4x, be careful. You will only do that when you need to get variables from one side of an equation to the other to get them to the same side. If they're already on the same side, you just combine them together like we did on this one. All right, let's keep moving. All right, so on this example here, it says find the values of x and y. Okay, two different variables they want us to find. All right, go ahead and take a second, copy this example, we'll do it together. Okay, so finding x and y. Here's the first thing. When you get a problem like this on these types of examples, we want to find one variable first, and then we'll use it to find the other variable. All right. When we decide what variable we want to find first, look at your your different values in your angles, and we want to use the ones that we have the most of. Okay. Right now we only have a single y. Okay, and we could not make an equation because we don't know what this angle equals. Okay, so we couldn't figure out y right now. It wouldn't be possible. But we can figure out x. If you guys notice, this angle here and this angle here, they both have x's in it. All right, here's the big thing we need to realize. These two angles make a flat line. Let me highlight it in green. Okay, and if you guys remember, two angles that make a flat line, first of all, it shows up all the time. Always look for two angles that make a flat line. All right, but the big fundamental thing to remember is those two angles add to 180. Technically, they're considered supplementary angles. All right, so that's where we can start. We know that these two angles, when added together, equals 180 degrees. Okay, so let's go ahead and make our first, let's make our first equation. Sorry, let me delete this stuff. Okay, so I'm going to start with this one. So I know that this angle, 8x plus 26, plus this angle, 3x, I know they add together to equal 180 degrees. That's the hard part. Okay, if you can do that, if you can make the equation, everything kind of falls into place. So let's go and do it. So 8x variables on the same side, I can go ahead and combine them. So an 8x and a 3x gives me an 11x. Okay, this 26, I'm just going to go ahead and bring down, nothing to combine it with, equals 180. Okay, and because I'm lazy, I'm going to go ahead and grab my calculator. I know I'm subtracting 26 as my first step for solving from 180. That gives me 154. So I'm getting 11x equals 154. And then I know I'm dividing both sides by 11. And it looks like I'm going to end up with a nice clean number for x. X equals 14. All right, so we found one of our answers. We figured out what x is. Wonderful. But we are not done. We now need to use that to figure out what y equals. All right, so how do we do that? All right, we actually have some options. Okay, first things first, now that we know what x equals, we could plug it in to either one of these angles and figure out what its measure is and maybe use that to help us. All right, so let me show you the two possible ways of doing this, and you guys will see throughout this class, sometimes there's multiple ways of finding your answers because you're going to learn so much about these angles as we go along. Okay, here's the two things we know right now. We know that this angle, the 5y plus 38, and this angle are vertical angles. All right, I could make my equation. I could say that this angle equals this angle and then plug in my 14 and I could figure out what y equals from there. Here's my other option. I know that this angle here, the 5y plus 38, and this one, 3x, make a flat line. Okay, another way of finding out what y equals would be to say that this angle plus this angle equals 180, plug in 14 and solve. Okay, either way, you're going to get the same answer. Do whatever you think is going to be easiest. I think in my brain, it's easier to just set these vertical angles equal to one another. Okay, so that's what I'm going to do. If you want to try it the other way while I do this and see if we get the same answers, go for it. Okay, so I'm going to go ahead and say that this angle, 5y plus 38, is equal to 8x plus 26. All right, this right here is impossible to solve, but now that we know what x equals, we can plug it in, and then we'll just have the single variable, the y, to solve for. Okay, so that's going to be my next step. So 5y plus 38 equals 8 times x, which we figured out was 14 plus 26. Okay, now we can do a little bit of simplifying. On the left here, I'm just going to keep it the same for now. My 5 is starting to look like an S. Let me try that again. 5y plus 38 equals, and over here I'm just going to use my calculator. So 8 times 14 is 112. 112 plus 26 gives me 138. Okay, get a calculator, guys. It's going to make your life so much easier. You can use it anytime in this class. Okay, so from here, I'm solving. So I'm going to subtract 38. And I'm going to get 5y equals nice clean 100. And now I can divide both sides by 5. And 5 goes into 120 times. And there we have it. I have figured out what y equals. All right, so that's some good geometry right there. That is like some fundamentals in this class. We needed to know, relationships of angles. We needed to know how to solve and plug in numbers. Like, this is a good problem. There's a lot of work, but hopefully it at least kind of made some sense to you. All right, guys. So I'm going to have you go ahead and try a problem a lot like this. Okay. So after you guys copy this down, just take a notice. We're finding x and y. We again have multiple angles that have an x in it. I would start with these two angles. After you find out what the value of x is, then you can create another equation to find out what y equals. All right. So to just kind of get you started here, if you guys notice, these two angles here make a flat line. Okay, go ahead and make an equation out of those and solve for x. All right, So hopefully you realize, oh, two angles make a flat line. They must add to 180 degrees, just like we did on the last problem. And again, you're going to see that a lot in this class. So that's where I'm going to start. This angle, 9x plus 20, plus this angle, 7x, equals 180 degrees. Sorry, let me make this look a little nicer. Okay, so there it is. Now we can go ahead and solve for x. Again, I noticed that we have variables on the same side. I can go ahead and combine those. Looks like I have a 16x, bring down the 20, equals 180. And solving this thing, I'm going to subtract 20 and divide by 16. All right, going through it quick, but if you need to pause the video, feel free. All right, and there it is. I figured out what x is. I'm halfway done with my problem. All right, here's the next thing. Now, how can I figure out what y equals? All right, so hold up real quick. Let me delete this if I can. Okay, so here's where you have options, and I'm going to have you try this on your own if you haven't yet. But I noticed that, okay, obviously I want to use this angle that has y. Okay, here's what I noticed. This angle and this one make a flat line. I can make an equation out of that. Here's another thing I noticed. This angle and this angle are vertical angles. I can make another separate equation out of that. You just need to choose one of them and see what works best, or do whichever you think looks easiest, and then see if you can solve for y. Make sure to plug in your value of x after you make your equation. Try it out. All right, so if this were me, I think it's a lot easier to notice that these are vertical angles, and that means they are equal. So I know that 2y is equal to 7x, right? Right now, that's impossible to solve if I didn't know what x equals, but I do. So let's go ahead and plug it in. So 2y equals 7 times x. 7 times, we figured out that x was 10. All right, and yeah, some nice numbers here. Looks like 2y equals 70. And when I divide both sides by 2, it looks like y is going to equal 35. All right. So yeah, I as a math teacher, really like these problems because they are covering so many things that you're going to see so often. Setting things equal to one another and adding things to equal 180. Oh yeah, it's going to show up a lot. All right. So let's see where we're going. All right. That's going to be that for today, guys. We'll have an assignment on this tomorrow. Hop into the Google Meet if you have any questions. But yes, I'll see you guys then. Bye.